Hello everyone, welcome to the first video for this week. So this week is all about logarithms, and this is the last set of videos before test 2. Logarithms are kind of funny things. They take a little bit of time to get used to. It took me a while as a student to kind of get used to what they were saying. I remember like coming home from school, getting off the bus, going on long walks in my neighborhood, trying to think about what logarithms really meant. And it takes a little time. So even if you've seen, I think the first video, you might have seen some of this in a previous class, like 112 or your class in high school. I apologize for that if it's a bit boring, but like I said, these take some time to get used to, and it's probably not a bad idea to see it more than once. So logarithms are kind of the answer to a lot of our prayers because they make dealing with exponential functions, and especially exponential equations, much easier than the kind of ad hoc stuff we had to do in the last week's videos, and especially the video from the beginning of last week. So let me motivate logarithms a bit. Logarithms can be a bit tricky to get used to. But they allow us to deal with exponential equations, to solve much more easily. Okay, so let me just give you like an example. Well, example of something we did, and I'll kind of modify it. And you'll see where we get stuck. So last week we considered exponential equations of the form like things like 3 to the 2x equals 9, say. Okay, and so the whole point was to solve for x, right? And so what you would do is you'd say, okay, 3 to the 2x is 9, which is 3 squared, right? So we have this exponent involving 3, with a base of 3 is equal to this exponential with a base of 3. So that means that 2x had to be equal to 2. And that's the same thing as saying that x is equal to 1, right? So, we could solve this equation by writing everything as a power of 3, right? And then equating the exponents. So that was our strategy last week. Now, what if I modified this slightly, right? What if instead we have the equation. Sorry, the cat is doing cat stuff. There it goes. E to the 2x equals 9, where this e is our friend, 2.718, this crazy irrational number that's so important is Euler's number. Okay, now if you wanted to follow the same strategy as before, right, you'd have to write 9 as a power of e. But we can't do that. We don't know how to do that. It's not obvious how to express 9 as e to the a for some number a. So the old technique of doing this doesn't really work, right? We need a new idea to be able to solve this kind of equation, and this, which comes up a lot in applications because, like I said last week, this number e is just so powerful. It comes up everywhere. Don't chew the cord. Sorry. No. He's being very, very rambunctious this morning. You should be napping. Nap time. Okay. Right. We can't write 9 as a power of e. So we need a new idea, and that new idea is logarithms. So we'll be able to solve this with the use of logarithms, which gets around this issue of being able to know how to write 9 as some power of e. So we don't know. So problem. We don't know how to express nine in the form nine equals e to the a for some a, and for some number a. And use the technique from last week to solve the equation. So that's a conundrum. So the solution to this problem is to introduce a new function called the natural logarithm. That essentially does the work for us. Okay, so that's what I want to talk about now. And what's with this new function, like I said, it's kind of a weird function. It takes some getting used to. But with this new function, all your dreams come true and you don't have to do any difficult thinking once you understand how to play with it. Okay, so here's the definition. The natural logarithm function, oops, is denoted y equals ln x. Okay, so that's the function. And is defined, so ln is like logarithm naturel in French, logarithm naturel, but it's natural logarithm. English, we'd say it the other way. And it's defined by the condition y equals ln x if and only if e to the y equals x. So this is the most important defining equation of our friend, newfound friend, the natural logarithm. Okay, now it's important to say what this means in words, okay? And I think like I was telling you, like I had trouble with this as a student. I kept going on these walks and thinking about what this meant. And I would repeat to myself the kind of following phrase. So the natural logarithm of a number x is the number y you have to raise e to obtain x that you started with. Oops. Okay, let's look at that again. So the natural logarithm of x is the number y that you must raise e to get x. So y equals ln x is the same thing as saying e to the y equals x. So the logarithm of x is the number you have to raise e to get x. And if you can internalize that, you're done, basically. That's half the battle. I mean, there's a few other things you need to understand, but once you have that in your head, you'll understand why the logarithm does what it does. Okay? All right, so I should just say like a remark. So like I kind of said this, but I should make this very clear. So ln x is called the natural logarithm of the number x. Logarithm, and sometimes people just say log of the number x. Okay. Where I come from, they used to say it's called, I hope they don't do this anymore. Sometimes I might call it ln x, but hopefully I won't do that. Most people pronounce this ln x. It's usually pronounced ln. Ln x. What else do I need to? There's some other funny things that might happen, but probably you won't encounter them. So I'll leave that out for now. All right, so we need to start playing with this because, like I said, this takes some time to get used to. And never, I should call this, I should give this equation a name. It's so important. So I'll call it string. Okay, so examples. So what is the natural logarithm of e? Well, e is e to the 1. What number do you have to raise e to get e? You have to raise e to the 1th power to get e. So the logarithm of e is 1. Natural logarithm of e is 1. Now we'll just kind of play this game. What's the natural logarithm of e squared? Well, what number do we have to raise e to get e squared? Well, e squared is e raised to the 2. I'm just saying the same thing, right? So is e raised to 2nd power so the logarithm of e squared is 2. In fact, using that same logic, for any real number r, the logarithm, natural logarithm of e to the r, right, is just r. Because what number do you have to raise to raise e to get e to the r? Well, you raise e to r. So it's almost like it becomes tautological. It's like whose berries and Grant's too? Grant, right? Like what number do you need to raise e to get e to the r? By definition, you raised e to the r to get e to the r. So the logarithm of e to the r is r. Okay, for any real number r. You can kind of keep playing this game and we'll have fun with it. So what's the logarithm of 1? Think about this for a moment. You need to recall, for any real number a, we have a to the 0 is 1. So in particular, e to the 0 is 1. So again, going back to this definition, it's kind of gone up here, definition star, right? The logarithm of 1 is the power you have to raise e to, it's the number you have to raise e to get 1. So e to the 0 is 1. So the number we have to raise e to get 1 is 0. So that's another important thing to keep in mind. So let's do an example that's not so stupid. This is from the homework. I'm not gonna tell you which one, but I'm doing some of your homework, so just be happy. Which one did I do before? Okay, so find the logarithm of the 5th root of e to the 6th, the natural logarithm. Okay, so, well, we have to remember how rational powers work. And hopefully, if you've done enough power rule problems, you remember this. But we haven't seen these in a while, so it could be kind of weird. So we need to recall that a to the p over q is the same thing as saying the qth root of a to the p. Right? So for example, if you remember, in power rule problems, we had things like x to the 3/2. So that's the square root of x cubed. So looking at this puppy, we see that we got logarithm, natural logarithm of the 5th root of e to the 6th. Oops. But okay, e to the 5th root of e to the 6th, according to our discussion here, right? This is e to the 6/5. So this is the logarithm of e to the 6/5, which, if you remember what I said just here, that for any real number, right, the logarithm of e to the r is r, but this is just 6/5. Done. It's shockingly easy once you understand what the logarithm is doing. Right, so what number do you raise e to the 6/5 to get e to the 6/5? You raise e to the 6/5, and that's what the logarithm returns. I mean, it's like I'm saying the same thing over and over because it's just definitional. Okay. You know, we could keep going on. There's several other problems like this, but I promised you that we would use this to solve equations. So using logarithms to solve equations. So where was the equation we started with that I was messing around with? There it is. Okay. Let me copy this guy. So solve the following equation for x. So e to the 2x equals 9. Okay, so like I said, we don't know how to write 9 as a power of e by sight. Nobody can do that, okay? But the logarithm gets us around this problem. So here's what we do. So take the logarithm, the natural logarithm of both sides. So you have ln of e to the 2x equals ln of 9. Okay? And now recall what I was saying above, that ln e to the r equals r. By definition of what the logarithm is doing for all real numbers r. Right? By definition of what the logarithm is doing. So in particular, the logarithm of e to the 2x equals 2x. Right, so what number do you have to raise e to the 2x to get e to the 2x? Well, that's clearly 2x, right? So if I say that enough, maybe you'll internalize it. I mean, that's how I internalized it. So this equation becomes So the above equation becomes 2x equals ln 9. And now you just solve this x equals ln 9 over 2. Done. So the logarithm did this work for us of extracting the x from the exponent, which we could not do because we did not understand how to write 9 as a power of e, and then we equate the powers like we were doing last week. We didn't know how to do that. But the logarithm does the work for us of extracting the power of x from the exponent of e. From the exponent. So I think it's a very, very powerful tool. This is why it's such a powerful tool. Okay, and then, okay, so what do? I mean, what is this number? I mean, you look on your calculator. On your calculator, you'll see an ln button. So you'll punch in to your calculator ln of 9. It's some irrational number. I can do it now if you want. It's not terribly exciting. And we're lucky, I'm young enough even that this didn't happen in my generation, but we're extremely lucky that we have calculators that can do this, because in my parents' generation, they didn't. And you had to look this up with tables. And that was a bloody nightmare. So if you want to, you plug in ln 9 into your calculator, and this is approximately equal to 2.19722, some garbage or whatever, and it keeps going. It's irrational divided by 2. So you'll get some approximation. The calculator will give you some approximation of this logarithm of 9. Mostly this is irrational. Let's do another example since we're on such a roll. Here's a good one. Let's throw a little bit more complicated thing into the mix. So another example. Get rid of this window. Solving an exponential equation. So we get 4e to the x over, so solve the following. So I should say, sorry, solve the following equation. So 4 times e to the x over 8. Oh, x over 8, I'm sorry. Minus 9 equals 0. Okay, this is a little trickier of an exponential equation, but we can do it. So the strategy is the following. We can't go and take the logarithm of both sides immediately now, because if we do that, we don't know how to simplify the logarithm of 4e to the x to the 8 minus 9. There's no way to simplify that. So with these equations, when you get to something that's a little more complicated like this one, your first step has got to be to isolate the exponential term. Okay, so first, isolate the exponential term. Completely on one side of the equation. Of course, it doesn't matter which side, but just pick one. After you've done that, after you've completely isolated the exponential term, then you can take the logarithm, natural logarithm of both sides. Then take natural logarithm of both sides. And the third step, is solve the resulting algebraic equation. Okay, so once you take the natural logarithm of both sides, you will get the x, the terms involving x, out of the exponents. You'll have some algebraic equation involving x that you can solve, just like we did here. What I mean by that, we had this, right, that taking the logarithm removed the 2x from the exponential, and then we had to solve this equation, this algebraic equation of 4x. And we solved this 2. Oh, so things froze a bit here. So let me just say that again. So we had to solve this algebraic equation just by dividing by 2. Okay, and then we can put it in a calculator if we wanted to, if you want an approximation. All right, so let's do this. Let's execute these 3 steps with this this equation for e to the x to the 8 minus 9 equals 0. So this guy here. So let's see. So 4 times 4 times e to the x over 8 minus 9 equals 0. So if we isolate the exponential, I'm going to move the 9 over to the right hand side. So we'll get 4 times e to the x over 8 equals 9. And then I need to divide by 4. And so then I get e to the x over 8 equals 9 upon 4. Now I can take the logarithm of both sides, natural logarithm. ln of both sides. And so you get ln e to the x over 8 equals ln 9 over 4. And so then you get x over 8 equals ln 9 over 4. That's the magic of the logarithm, right? So that's, again, using this lovely property, e to the ln e to the r equals r for all r. Right, and so now we just solve this algebraic equation. In this case, we multiply by 8. So you get x equals 8 ln 9 over 4. And that's our solution. And you can put it into a calculator for an approximation. I do not think the homework actually wants you to do that, but you might be interested to see what the number you get actually is, if you like. So I won't do that with this example, but by all means, if you're interested, plug this into an equation and see under your calculator and see what you get. Okay. Now I want to talk about a little bit about going the other way, namely about solving logarithmic equations. And then we'll do more of this in the next video. Well, yeah, we'll do more of this in a bit, but we'll start off basically very, very safe, easy equations. Okay, so here's the example I want to discuss. Solve the following equation for x. So ln 5x equals ln 6. So to do this, we need to get the x, or the 5 times x, out of the logarithm. And this is easy to do if we remember, if we look at the logarithm in a slightly different way than we've been doing so far. So we need to solve this equation. We need to make another observation about the logarithm. Okay, so we had this observation that ln of e to the r was R for all numbers R. Right? So in other words, remember the logarithm is giving you the power, the number you have to raise e2 to get the number inside the logarithm, right? So recall that y equals ln x if and only if e to the y equals x, right? So that's how we got this guy. So what about if I do the following? If I take that idea and kind of run it the other way, how do we evaluate, or what is the quantity e to the ln x? Okay, so let's look at this. Look at this equation very carefully. Right? Ln x equals y. That means that e to the y equals x. So ln x is a number we have to raise e to get back x. So if we raise e to the number we have to raise e to get x, we just get back x. So they cancel each other out. So it's the kind of reverse of this situation, right? So taking the logarithm of the power of e just gives you the number in the exponent. Taking the exponential of the logarithm of x gives you back x. So that's why I wanted to mention them both. So there's two sides of the same coin used in slightly different ways. So this is an extremely important thing. So again, the logarithm of x is the number you have to raise e to get x. So if we raise e to that number, we get back x. That's the definition. Okay, but this tells us how to get rid of the logarithm. So in much the same way that taking the logarithm got rid of brought the power out of the exponent, right? If we exponentiate both sides of this equation, that will bring the numbers, that will cancel out the logarithm. That'll bring the numbers out of the logarithm. So let me just write it again here. So to solve, the logarithmic equation, ln 5x equals ln of 6. We use the I call this maybe call this double star. We use double star, and so we exponentiate. Let me say it this way: we exponentiate both sides of the equation and use double star to remove the logarithm. All right, here we go. So we get e to the ln of 5x equals e to the ln of 6. Now using double star, right, the e's and the ln's essentially cancel out, giving you 5x equals 6. Now, and now you have an algebraic equation. So now we say that x equals 6 over 5. It's easy. So, it's like, what's e to the ln of 5x? Well, ln of 5x is a number you have to raise e to get 5x. So if we raise e to the ln of 5x, we just get 5x. And similarly here, you just get 6. They cancel. So you get 6 over 5. So here's another kind of simple mantra or kind of slogan. To solve exponential equations take logarithm of both sides, take natural logarithm. I mean, you have to, of course, isolate the exponential. I mean, after isolating exponential, but that's too long for a slogan. And to solve logarithmic equations, take the exponential of both sides. After isolating the logarithm, again, too long for a slogan, but this is roughly how it works. Okay, this part actually, so no, this part, unfortunately, with logarithmic equations is more challenging. So let me demonstrate what can happen here. So, and then maybe we'll do this in the next video. So so in the previous equation, here it was, we didn't have to really isolate the logarithm in any sense. I mean, both sides were just written as pure logarithms. So we could just exponentiate both sides and then use this double star and have the logarithm and the exponential cancel, and you got some very easy equation to solve. But what happens with this kind of situation? Solve the following equation for x. Logarithm of x minus logarithm of x squared plus the logarithm of 6 equals 0. This isn't so easy what to do. So to be able to use double star to solve this equation, double star above to solve this, we have to write the left-hand side as a single logarithm. And right, because you need, what does this say, right? I'll just write it here. The double star says e to the ln of x is equal to x. That's what the equation double star says, right? But we don't have ln of a single x. We have ln of x minus ln x squared plus ln of 6. And that if we just exponentiate that, it's a mess. So what you need to do is we need to understand, to be able to solve this equation nicely, we need to be able to understand how to combine logarithms into a single logarithm using properties of logarithms. So to write the left-hand side, as a single logarithm, we need to understand the properties of logarithms, to understand algebraic properties. Of the natural logarithm function. Okay, so that's where I'll start off in the next video. I should just end, I was debating about whether or not to say this, but I should probably just end with a little bit of explanation about what's happening on the calculator. So in the calculator, if you have any standard calculator, you'll notice, so on your calculator, so it's kind of a remark, on your calculator, you will notice a log button and an ln button. So for now, this is the button that this is the function we're using, even though it's called a logarithm. And sometimes I just say it's a logarithm rather than, I've sometimes dropped the word natural in the discussion. This is a different kind of logarithm. This is logarithm base 10. So the function log on your calculator is the logarithm base 10. So in other words, and again, just so you're aware, so y, this is defined as follows, y equals log x if and only if 10 to the y equals x. So it's the number you have to raise 10 to get x. And the exam, for example, like the log of 100 is 2. Now we won't use this in this class much at all, if at all, but it's there, and don't confuse it with the ln button. It's very useful in physics and engineering. And unfortunately, this caused me a very embarrassing moment when I was in college. In Central Europe, they use this for this symbol for the natural logarithm. And one of my professors was Russian. He recently immigrated, and we were in class, and he wrote something like log of E and asked us what it was, and like we were dumbfounded. I think he thought we were all idiots. And then he realized that that we thought we were used to it being the logarithm of base 10. But you probably won't encounter this kind of thing anymore. But just so you know, that's the difference between the two buttons on the calculator. And there can sometimes, with some people, be confusion about which one to use. This shouldn't happen to you, I mean, I think, anymore, but just so you're aware of it, and it's kind of a funny story. And once he realized that we were confused, I think he thought a bit better about us, but at the time he looked really disappointed. Okay, so that's enough for now. So in the next video, I'll talk about, I will talk about the properties of logs and explain to you, we'll do some examples, and then we'll come back and solve this equation. Okay? Thanks for tuning in.